What's up, everybody, and welcome back to OpenStax Algebra and Trigonometry, Chapter 13, Section 4, Series and their notations. Let's do it. Question number 1, what is an nth partial sum? So a series is basically a summation of a sequence of numbers, right? So let's say we have 1, 2, 3, 4 as an arithmetic sequence. We're talking about a sum, more particularly a partial sum. It means we're summing, for example, the first 4 terms in this case of the sequence. Now we could do a fifth partial sum. We'd sum the first 5 terms, so on and so forth. So that's how you do it. Done. What is a geometric series? A geometric series is basically the summation of a geometric sequence. And a geometric sequence, if you remember from the previous section, is where there's a common ratio between consecutive terms. So an example would be 2, 4, 8, 16, where the common ratio is 2, right? We're doubling every time. So again, that's how you do it. Done. So what I'm going to do is I'm going to read the answer from the back of the book, and then I'm going to kind of explain it. So it says an annuity is a series of regular equal payments that earns a constant compounded interest. So basically you're getting paid. If you're collecting an annuity, you're getting this payment on a monthly basis or a regular basis with the interest factored in. So here we're going to express each description of a sum using summation notation. So again, we're taking the sum from n equal to 0 to 4 of 5n. That's the term. So you see, I wrote it out as I was saying it, but that's how you do it. Done. The sum that results from adding the number 4 5 times. So if we're talking about a summation where we're simply adding 4 over and over again, we got a 4 right here for the argument, and that we don't need any variable there. And then we're doing it 5 times, so we could say starting at a count of 1 and going to 5. Now in the back of the book they had k instead of n, but that's going to be arbitrary here. So anyways, that's how you do it. Done. So for this one, we want to represent this in summation notation. Again, it's an arithmetic sequence with a common difference of 8. So to figure out the summation notation, I need to first figure out what term this is in the sequence. So let's get our formula. A sub n equals the first term plus the common difference times n minus 1. And we're trying to figure out what value of n is going to get us a term of 162. So we got 162 is equal to 10 plus 8n minus 8 as I distribute. Then these are going to combine to be 2, right? So then as we finish this off, we're going to minus 2 from both sides. And we're going to get 160 is equal to 8n, divide by 8, and we see that n is equal to 20. So this is the sum of the first 20 terms. Now, for summation notation, we can say summation n equals 1 to 20. And now what do we need in the center? We need this term that is simplified here, right? When we simplified, we'd get 8n plus 2, right? And that's what goes in here, 8n plus 2. Now again, in the back of the book, instead of n, they have k, but again, that letter is arbitrary. So this is how you do it. Done. For the following exercises, use the formula for the sum of the first n terms of each arithmetic sequence. So here's our arithmetic sequence series formula, and here's our geometric series formula. So for this one, we've got 1, 2, 3, 4, and 5 terms. So it's the first 5 terms. So we're taking the sum of the first 5 terms, and we're starting with the first term, a sub 1, plus the fifth term, 7 over 2. And this is all over 2 times n, and n in this case, since there are 5 terms, is 5. All right, now let's simplify it. 3 halves plus 7 halves is 10 halves. 10 halves is 5, so we got 5 over 2 times 5, which equals 25 over 2. And that's how you do it. Done. So for this one, we can see that the common difference is 0.2. So the question is, first of all, what is this term? So let's come up with our nth term for this arithmetic sequence, an explicit formula. So a sub n is equal to my first term, 3.2, plus the common difference, 0.2 times n minus 1. And what we're going to do now is we're going to figure out what is n when the a sub n term is 5.6. So we got 5.6 is equal to 3.2 plus 0.2 n, and I'm going to distribute, minus 0.2. Now we're going to solve for n. First, let's combine these guys. That's 3, right? 3.2 minus 0.2 is 3. So 5.6 equals 3 plus 0.2n. Now we're going to minus 3, and we've got 2.6 is equal to 0.2n. Then we're going to divide both sides by 0.2, and we've got n is equal to 13, right? 0.2 goes in 13 times. So we now know that this is the 13th term. So the formula, therefore, will be S sub 13, so the sum of the first 13 terms, is equal to the first term, 3.2, plus the last term, 5.6, divided by 2, times however many terms there are, which there are 13. Now, in the back of the book, they didn't evaluate this, but I'm just going to do that anyways, just so we can see. That becomes 8.8 over 2, which is 4.4. And then 4.4 times 13 is going to be 52 plus 5.2 is 57.2. So that's how you do it. Done. So for this one, we have to express this using summation notation. But in order to do that, I need to figure out what this term is in the sequence. So I can see that my a sub n explicit formula will be my first term times the common ratio, which is 1/2, right? I'm taking 1/2, I'm taking 1/2, etc. So it's a common ratio, 1/2 to the n minus 1. I'm trying to figure out for what value of n are we going to get 0.125. So let's write this out, and then we are going to solve for n here. So first I'm going to divide both sides by 8, and we have 0.125 over 8 equals, and then let's make that 1/2 0.5 to the n minus 1. So this then reduces to 0.015625 is equal to 0.5 to the n minus 1 power. So the question is, what power do I have to raise this to get this? And what it's going to be is 0.5 to the 6th power, meaning n will have to equal 7. So this is my 7th term in the sequence. Now, if we want to represent this using our summation notation, we say summation from n equals 1 to 7, and we have to put in our explicit formula for the term here. So it's 8 times 1/2 to the n minus 1. There's your summation notation. That's how you do it. Done. For the following exercises, use the formula for the sum of the first n terms of each geometric sequence and then state the indicated sum. So we've got 9, 3, 1, 1/3, 1/9. So here's my formula for a geometric sum, okay? And it is a sub 1, which is this term, right? 1, 2, 3, 4, 5. So we got 9 times 1 minus, and then what's the common ratio? Well, every time we're multiplying by 1/3, 1/3, 1/3. So it's 1/3 to the n power, which is the amount of terms here, which will be the 5th power. And then this is over 1 minus 1/3. So here, as we put it into decimals, we get 13.4 repeating in fraction format, 121 over 9. So we'll say 121 over 9 for the win. Boom, done. So for this one, once again, we've got a geometric series, and we want to represent this using this formula. So we're going to take the sum of the first 11 terms, right, from 1 through 11. And so we're going to have the first term, which is right here in that sequence formula of 64, times 1 minus the common ratio, which we can find right here as 0.2 to the n power. In this case, n is 11. And then this is over 1 minus 0.2. Let's plug and chug into Desmos. So what we end up getting is 79.99999 and all these other numbers. So we'll round it to approximately 80. So we'll say the summation is approximately 80. That's how you do it. Done. So this one is an infinite series, and what it looks like to me is a geometric infinite series. What we're doing is we're multiplying every time by 4/5, right? And since this common ratio is less than 1, it means it will indeed have a finite sum, okay? And to get that formula, it's a sub 1, which is 2, over 1 minus the common ratio, which is 4/5. So 1 minus 4/5 is 1/5. So it's 2 divided by 1/5, which is the same as 2 times 5, which is 10. So the sum does exist. It is 10. That's how you do it. Done. So for this one, this is a geometric series, and I know since the common ratio is between 0 and 1 in its absolute value form, this is going to have a summation. So to get the summation of this infinite series, by the way, this is a typo, I believe. It should be k equals 1 down here and infinity up here, right? So to get this, we're going to do the first term when k is equal to 1. You plug it in, 1 minus 1 is 0. Anything to the 0th power is 1. Tagged with a negative is -1 over 1 minus r. And the r value is this. It's that -1/2. Now, they left it like this in the back of the book, but we can simplify it just for fun. And it's going to be -1 over 1 plus 1/2, which is 3/2. -1 over 3/2 gives us the reciprocal of 3/2, which is -2/3. And that's the sum. It does exist. Done.
So for this one, it says Javier makes monthly deposits into a savings account. He opened the account with an initial deposit of $50, and then each month thereafter, the deposit increased by $20. So it sounds like an arithmetic sequence where each month, right, we'll start with that initial value. Month one is 50 plus 20, and then it's going to be times n minus 1, right? That's going to be for each month. So the first month, we're going to have 50. The second month, when you plug in 2, we're going to have 70. And the third month, we're going to have 90. But when we're talking about the arithmetic sum, right? Each sum, it's going to be 50. Then 50 plus 70 is 120. Then 120 plus 90 is 210. So on and so forth through month 12. So let's check that out in Desmos on the graph. So here are all the values: 50, 120, 210, all the way down to 12 months, showing that the final sum for the 12 months is 1920. That's how you graph it. Done. So for this question, it says, what number does S of n seem to be approaching in the graph of this arithmetic series? So we're going to graph it in a second, but I'm going to show you using our formula for an infinite sum where we know it's going to be a finite value because this is between 0 and 1. I'm going to show you what it is first, and then we can figure out on the graph that it should indeed be approaching that value. So it's going to be the first term where I plug in 1, which is going to be 1/2 divided by 1 minus 1/2, right? So 1 minus 1/2 is 1/2. 1/2 over 1/2 is, of course, 1. So it should be approaching 1, but now let's look at the graph. So now as we look at the sum of the first 7 terms, right, look where it's approaching. It's at 1/2, 0.75, 0.875, and it's getting closer and closer to 1. So that's how you do it. Done. So for this one, we're meant to find the indicated sum starting from 1 and going to 6. So we're going to plug and chug. And what I might do is I might even simplify this expression a little bit just to make it easier. So it's going to be n squared minus 2n. Okay, so my first term plugging in 1 is going to be 1 minus 2, which is negative 1. Plugging in 2 is going to be 4 minus 4, which is 0. Plugging in 3 is 9 minus 6, which is 3. Plugging in 4 is 16 minus 8, which is 8. Plugging in 5, that's 25 minus 10 is 15. And last but not least, plugging in 6, that's 36 minus 12, which is 24. Now we need to take the sum of all of these. So negative 1 plus 0 plus 3, that's 2. Then we have 10. Then we have 25. And then we have plus 24 is 49. That's how you do it. Done. So for this summation, it looks to be powers of 2. Okay. And this is actually a geometric series. So the first 7 terms are going to be plugging in 1. So we got 2, 4, 8, 16, 32, 64, and 128. So we could go ahead and add these up, or we can use the formula for a geometric series. Just for fun, we're going to use the formula, and we've got the first term, which is a sub 1, which is 2 in this case, times 1 minus the common ratio, which in this case is 2, right? It's doubling every time. So plug in 2, and then to the n, which is 7 over 1 minus 2. All right, so 2 to the 7th, 2 to the 5th is 32, then 64, then 128. So 1 minus 128 is negative 127 on top. And then over 1 minus 2, that's negative 1. So you can see the negatives are going to cancel. 2 times 127, therefore, is 254. So that's how you do it. That's the sum. Done. So for this one, we're meant to find the sum of this arithmetic series, where this is the first, second, third, fourth, fifth, sixth, and seventh term. But they don't want us to just add it up. They want us to use the formula for the sum, right? So in this case, the sum of the first 7 terms is going to be equal to the first term, which is 6, plus the last term, which is 15, over 2 times the number of terms that there are here, which is 7, okay? And that's the formula. So 6 plus 15 is 21, divided by 2 is 10.5, and then 10.5 times 7 is going to be 70 plus 3.5, which is 73.5. That's how you do it. Done. So this one is an arithmetic sequence, and as you can see just from plugging in 1, right, and 2, we can see the common difference. So if I plug in 1, it's 1/2 minus 1/2, which is 0. The second term when I plug in 2 is going to be 1 minus 1/2, which is 1/2. So you can see that the common difference is going to be 1/2, right? So now we have enough to use our summation formula. So we're taking the sum of the first 11 terms, and that's going to be equal to the first term where I plug in 1 and I get 0, plus the last term where I plug in 11. So that would be 11 halves minus 1/2, which is 10 halves or 5. So it's the first plus the last divided by 2, and then times n, which in this case is 11. So what you're going to get is 5 over 2 times 11, which is 55 over 2. And that's how you do it. Done. So for this one, we want to use the formula for a geometric series for a partial sum based on this sequence, right? And we want to find S sub 7. So what we need to figure out is I need to figure out the first term, which I already have as 0.4, and I need to figure out the common ratio. So I can look at just any two consecutive terms. Let's look at these two, right? I've got 10 and negative 2. 10 divided by negative 2 is negative 5. So that seems to be the common ratio. Now we have enough. So we want S sub 7, which is equal to the first term, 0.4, times 1 minus the common ratio, which is negative 5, to the nth power, which in this case is 7, over 1 minus negative 5. Let's plug this into Desmos. So once we plug and chug, we get 5,208.4, and that's the answer. Done. So for this one, we have what appears to be a geometric sequence in this sum with a common ratio of 1/2. Now to get the first term, we're just going to plug in 1. 1 minus 1 is 0. 1/2 to the 0th power is 1 times negative 2 is negative 2. So now let's check it out. So we want the sum of the first 10 values, right? So S sub 10 is equal to that first term, negative 2, times 1 minus my common ratio of 1/2 to the 10th power, again, that's this value right there, over 1 minus 1/2. All right, let's plug this into Desmos. And here, when you plug it in as a fraction, you get negative 1,023 over 256. And that's how you do it. Done. So for this one, we're trying to find the infinite sum if it exists. Now, it's only going to exist if the R value is between 0 and 1, absolute value, of course. So in this case, it definitely looks like it is because it's going down. And what times negative 1 gives me negative 1/4? 1/4. So now to get the infinite sum, okay, the formula is a sub 1 over 1 minus r. All right, my first term is negative 1, and my common ratio is 1/4. So it's negative 1 over 1 minus 1/4, meaning negative 1 over positive 3/4. Negative 1 over that will give me the reciprocal, which is negative 4/3. And that's the infinite sum. That's how you do it. Done. So for this one, we're trying to find the infinite sum. And again, we see the R value right here is 0.5. It's between 0 and 1. That means the infinite sum does indeed exist. And to figure it out, we take the first term when n equals 1, right? So if I plug in 1, that exponent goes to 0, and that just becomes 1 times 4.6. So a sub 1 is 4.6. My common ratio is this value, 0.5, right? That's the multiplier. That's the common ratio. So it's a sub 1, 4.6 over 1 minus 0.5, that common ratio. So 1 minus 0.5 is 0.5. 4.6 divided by 0.5 is going to be 9.2. And that's the infinite sum. Done. So for this one, we're meant to find the total sum with 24 deposits, each one being $150, but an interest rate of 3%. Now, the way we solve this is we take that interest rate at 3%, recognize that it's compounded monthly. So what we're going to do is we're going to divide 0.03 by 12, and we're going to add that to 1. So this is the rate at which each deposit is growing by. So 1 plus 0.03 divided by 12 is 1.0025. So 1.0025 is going to be my common ratio. My initial value is 150, right? So A1 is 150. And now we can make a summation, right? It's a summation of 24 values. So check this out. We've got sum of 24, which is equal to the first term, which is 150, times 1 minus my common ratio, which is 1.0025, to the nth power. In this case, that is 24. And that is over 1 minus 1.0025. Let's plug that into Desmos. So we get $3,705.42. So here is your final answer. Done. So for this one, we have an initial deposit amount of 100. That will be our A1. And we've got 120 total deposits with 10% interest rate compounded semi-annually. That's twice a year. So to get my R value, it's going to be 1 plus 10%, which is 0.1 divided by 2, because again, we're compounding it twice per year. That's going to be 1 plus 0.05, meaning it's 1.05. So we have our R value, we have our first term, and we have our N value. Now let's plug and chug. So we've got 100 for A sub 1 times 1 minus, and then it's 1.05
to the 120th power. That's 120 deposits, and that's over 1 minus r, which is 1.05. Let's plug it into Desmos. And then we get $695,823.97. So there's your final answer. That's how you do it. Done. So for this one, we want an explicit formula for a sub k terms. Okay, so let's think about this. So we're assuming this is an arithmetic series, and as we're starting from 0 to 6, that's 7 terms, and we're somehow getting a summation of 189. So using our formula for a sum for an arithmetic series, it's 189 equals our first term plus our last term. Let's just say A1 and A7, even though it's 0 and 6, same idea, divided by 2 times 7, the number of terms. So now as I simplify, if I divide both sides by 7, I'm going to get 27, right? 27 equals A1 plus A7 over 2. And since the average of these two is 27, if I were to write these out, 1 through 7, right, we can see that the average or the exact middle is going to be 27. So I know my fourth term is 27. Now, in terms of what the first and the last term can be, it's a bit arbitrary, right? Like I could say, I could have any common difference I want, but as long as we got 27 in the middle, this is going to work. So just as an example, if I go down by 9 every time, this would be 18. Then this would be 9, this would be 0. Now I go up by 9, I get 36, 45, and 54. Now if I were to add all these together, I'm going to get 189. So this is viable. Now since we're kind of pulling this back, right? Instead of 1, 2, 3, 4, 5, 6, 7, it's really 0, 1, 2, 3, 4, 5, and 6. Now we can start to piece this together. So I've got my explicit formula a sub k is equal to my first term, which in this case is going to be 9, plus my common difference, which is 9 times k minus 1. So you can see this is going to work. Plug in 1, I get 9. Plug in 0, I get 0. Plug in 2, I get 18, so on and so forth. So as we distribute and simplify, I get a sub k equals 9 plus 9k minus 9. These are going to cancel, and I get a sub k is equal to 9k. Now, this is what I found as a viable explicit formula. Also in the back of the book, they have a sub k equals 30 minus k. Now, this is also going to work because as you're going to notice, if I plug in 0 through 6, I'm going to still get values that when you sum them up, it's going to be arithmetic and we're going to get 189. So anyways, these are just two different ways to think about it. That's how you do it. Done. How many terms must be added before the series has a sum less than negative 75? So the way that we can do this is we can recognize this is an arithmetic sum or sequence, and it has a common difference of negative 2. So what we can think about is we can say, all right, we want to get this summation to be less than negative 75. Well, the formula is going to be a sub 1, which is negative 1, plus a sub n, which is what we're trying to figure out, times n divided by 2. We're trying to figure out when this is going to be less than negative 75. Now to get a sub n, we can put in the explicit formula and then actually solve this. So what is the explicit formula? It's going to be that first term negative 1 plus the common difference negative 2 times n minus 1. So we can distribute, and simplify. That's negative 1 minus 2n plus 2. These will combine to become negative 2n plus 1. So we can now rewrite this as negative 1 plus negative 2n plus 1 times n over 2 is less than negative 75. And now we can solve for n. So check this out. These are going to cancel out. Boom, boom. And then I got negative 2n times n, which is negative 2n squared over 2 is less than negative 75. These will cancel out. And I've got negative n squared is less than negative 75. Then we can divide both sides by negative, boom, boom, and that's going to flip the inequality. So n squared is greater than 75, meaning n is greater than the square root of 75. So let's see what that is approximately. And that is 8.66. So what we'll do, the trick is when n is at least 9. So we'll say 9 terms has to be greater than 8.6. 9 would be the whole number that would work. That's how you do it. Done. The sum of an infinite geometric series is 5 times the value of the first term. What is the common ratio of the series? So we're going to use our formula, right? And our formula for the sum of an infinite series is a sub 1 over 1 minus r. And it's saying that this sum is 5 times the value of the first term. So now we have an equation. Now we can solve. All right. So let's first multiply both sides by 1 minus r. So I've got 5a sub 1 times 1 minus r is equal to a sub 1. Now we'll distribute, and I got 5a sub 1 minus 5a sub 1 times r equals a sub 1. Now we're going to combine like terms, minus 5a sub 1 minus 5a sub 1. Cancel that out. Negative 5a sub 1 times r equals negative 4a sub 1. Now, last but not least, let's divide both sides by a sub 1, kills that, and divide both sides by negative 5. And r is equal to negative 4 over negative 5, but the negatives cancel out, and we got 4/5. Therefore, the common ratio is 4/5. That's how you do it. Done. Carl has 2 years to save $10,000 to buy a used car when he graduates. To the nearest dollar, what would his monthly deposits need to be if he invests in an account offering 4.2% annual interest rate that compounds monthly? So what we're going to do here is we're going to use our formula for these regular payments. We're going to take 4.2%, which is 0.042 as a decimal, and we're going to divide that by 12. Then we're going to add this to 1, right? So it's 1 plus the compounded interest rate, and we get 1.0035. So we have 1.0035, and we're talking about monthly deposits and for over a 2-year period, which is going to be 24. So the end value is going to be 24. Now, using our formula for a geometric sum, we're going to create the following equation. We want the sum to be 10,000. Now, we don't know what that initial deposit is going to be, or those monthly deposits. So that's our unknown. So we've got a sub 1, and then we've got 1 minus, my r value is 1.0035, and then it's raised to the nth power, which in this case is 24. And it's all of this over 1 minus 1.0035, that r value. All right, let's see what we get in Desmos, at least for this portion right here. So here we get 24.99. So it's approximately 10,000 equals A1 times 24.99 approximately. And so now to isolate, we're going to divide by this value. So we got 10,000 divided by this value, and it's approximately $400.14. Rounding to the nearest dollar would be 400, and that's how you do it. Done. A boulder rolled down a mountain traveling 6 feet in the first second. Each successive second, its distance increased by 8 feet. So this sounds like an arithmetic sequence. How far did it travel after 10 seconds? So check this out. After 1 second, it's at 6. 2 seconds, it's at 14. 3 seconds, it's at 22, so on and so forth. All right, so what I'm going to do first in order to calculate this, and this is going to be a summation, right? We need to know the first term, which we do, which is 6. And then we also need to know the 10th term, but I'm going to get an equation for finding the nth term, the explicit formula, and it's a sub n equals my first term 6 plus my common difference 8 times n minus 1. So to find the value at 10 seconds, we're going to plug 10 in for n, right? 10 minus 1 is 9. 9 times 8 is 72 plus 6 is going to be 78. So we know that the 10th value is 78. Now we can use our summation formula for an arithmetic sequence, which is the first term plus the last term divided by 2 times the total number of terms, which is 10. So 6 plus 78 is 84 over 2, which is 42, times 10, which is a total of 420. And the units are feet, so the answer is 420 feet for the win. Done. A pendulum travels a distance of 3 feet on its first swing. On each successive swing, it travels 3/4 the distance of the previous swing. So for example, 3/4 of 3 is 9/4. 3/4 of 9/4 is 27/16, so on and so forth. What is the total distance traveled when the pendulum stops swinging? So you may say, well, how many swings until it stops swinging? Well, it's kind of like an infinite sum, right? We're going to kind of assume it's going to go a little bit less, a little bit less. Technically, it may never stop, right? But this is an infinite sum. So we already know the common ratio, which is 3/4, right? It's multiplying by 3/4. And we also know the first term, which is 3. And the formula is a sub 1 over 1 minus r. So we have a sub 1, which is 3, over 1 minus, and the common ratio is 3/4. 1 minus 3/4 is 1/4. 3 divided by 1/4 is the same as 3 times 4, which is 12. So the answer is a total distance of 12 feet. That's how you do it. Done. I hope you guys enjoyed this video, and if you did, please click that like button. If you want to see more from the Scalar Learning channel, make sure to click subscribe. Thank you guys so much for joining, and I'll see you in the next video. Take it easy.